Okay students, now we are into the very next lecture of the inert gases. Okay, we are going to study some important points regarding the compounds of the inert gases. In the last lecture we have studied how to separate the inert gases and their introduction, we have studied. Now we are going to study about the compounds of inert gases. So there is a very important topic and the objectives also there. The topic is clatherates. What is the topic? Clatherate. Okay. So clatherate means basically when a organic solvent, this is the container containing the organic solvent. What are the organic solvent? It can be phenol or it can be hydroxyquinone. Phenol or hydroxyquinone, and into it inert gases are sent and then crystallized. Okay, so then there will be crystal formation. This is called as a crystal lattice. This is the crystal lattice. This crystal lattice is formed by what? Organic compound. So these are the phenol molecular hydroxyquinone. What are these molecules? Phenol or hydroxyquinone. So in the phenol or hydroxyquinone molecule, there will be our inert gas molecule. Inert gas molecule will be trapped. This red color, I think you are able to see it. This red color compounds are inert gases. This black color compounds are organic molecule. Okay. So organic molecule provide the place. They form the crystal lattice. In the crystal lattice, inert gases are being trapped. Okay. So such type of compounds are called as a clatherate. Now the organic molecule which provides the space, they are called as host. What they are called as? Host. Whereas inert gases which are getting trapped, they are called as guest. Okay. What they are called as? They are called as a guest. Next, these type of compounds are formed by only argon, krypton, xenon, and these are the three gases which can form. Okay, and helium, neon do not form. Helium and neon. Why they do not form? Because they are smallest. So for trapping, their size should be matching those molecular spaces. Intermolecular space should be sufficiently large. Okay, so if they are trapped here, they can go away because they are very small in size. Okay, so this is about the clatherate. Clatherate compound, is it understood, all of you? Okay, well, next we will go to the next topic. Okay, we are into the very next important objective. Okay, now we are saying that we are going to study about the organic compound, but inert gas compound. Okay, but how he could come to know? Till now we were thinking that inert gases are very much inert in nature, so they will not form compound. But who felt that inert gases also can form compound, and how he could come to know? Okay, so the person who is behind the preparation of the inert gas compound, especially xenon. Okay, so xenon is the first inert gas whose compounds are prepared. Okay, and how we come to know? Neil Bratlett is the first person who prepared the compounds of xenon. What are those compounds that we are going to study? But before that, how he could come to know? Okay, so during his experiment, he studied that platinum, PTF6. PTF6 is an excellent oxidizing agent. PTF6 is an excellent oxidizing agent. So it can oxidize even O2 molecule. It can oxidize what? Even O2 molecule. See here, O2 is becoming as O2 plus. That means oxygen is losing the electron. First of all, oxygen itself is a highly electronegative molecule, electronegative atom, and it is in the molecular state. So it requires a large energy. So how much energy it required? 1165 kilojoules. So that much energy can be provided by platinum, PtF6. So it is oxidized. So then he thought that xenon ionization energy is 1170, just a minute difference of 5 kilojoules. So he immediately felt that platinum fluorine PtF6 can also oxidize the xenon. So oxidize means ion. So ion means it can form the compounds. Once it can lose the electron, it can easily share the electron. Then he thought that definitely we will be able to form the compounds. And what are the compounds which can form? Most electronegative. It is very difficult to take out the electron or share electron from the inert gases. So even that is done by platinum F6. So we can do it easily for the sharing purpose, especially two elements. What are those two elements? Fluorine and oxygen. So fluorine and oxygen have capability to share the electron from the xenon. That's why compounds of xenon are three types, either fluorides or oxides. Third is Oxy Flourides. Okay. So why only those three? Is it understood now? Because they are highly electronegative and it is very difficult to take the electron from the xenon, and it is done by only most electronegative element. Suppose if you wanted to make some new experiment, which element you will choose? Fluorine is already over, oxygen is already over. Next element you will choose? Very good, nitrogen. If there is any chance, then the chance is with only nitrogen. So you can try and you can apply for the Nobel Prize. Okay, once you prepare a new compound with this concept, definitely you will be going for the Nobel Prize. Okay, so if you work out on that topic, then definitely there are chances that you will be future scientist also. Okay, so this is about the very important question. Neil Bratlett is the person who prepared the compounds of xenon, and what prompted platinum of PtF6 could oxidize O2. What is its value? 1165. And what is the xenon value? 1170. Okay, is it understood? So these two, Clatherate and this Neil Bratlett, very important objective. I hope you will be getting this question and concept is clear to all of you. Okay, bye. Okay students, now we have understood very important topic about the clatherates, very important topic who scientist made the compounds and what are the compounds. For easiness I have classified, I have given into the flowchart form so that it is easy to remember and easy to memorize. Okay, so these are the three compounds. As I told you, because of the high electronegativity of fluorine and oxygen, they are only can form compounds with xenon, because xenon requires the highest ionization energy. Okay, so first compounds, if they are made only with fluorine, xenon and only with fluorine, they are called as a xenon fluoride. And always remember, there will be even number of oxidation states only. Even number of oxidation state only. Why? Because their general configuration is NS2NP6. Okay. Now for forming the compound, there should be unpaired electron. What there should be? There should be unpaired electron. So NS2NP6, ND it will going to use for sharing. So if one electron goes, two unpaired electron. So +2 oxidation state. If second electron goes, then 4 unpaired electron. This also will become unpaired. This is also will become unpaired. So 4 unpaired electron. That means what it is going to be? +4. Then if this is also goes 6. If this is also goes, then 8. So there is no chance of the +3, +1, +5, because it can provide even number of unpaired electron only. So you can even find out here also. So like XeF2, what is the oxidation state of xenon? +2. +4, +6, +6, +8. So like this, these are the compound where you will find only even number of oxidation state. Okay, so in the fluorides, how many are there? 3. In oxide, very difficulty due to formation of the pi bond. Okay, XeO3 and XeO4, and there is a lot of combination possible between the oxygen and fluorine. That's why XeOF2, XeO2F2, XeOF4, XeO2F4, XeO3F2. These are the some compounds of oxy fluorides. Okay, so one by one we are going to study about the structures. Is it understood? And reaction wise you can read and understand, but main problem comes only logical explanation of this structure. Until unless I explain how it is, why only like this, then you will not be able to understand. But reaction wise you can go through the books and you can understand the reaction. Writing reaction is not a problem. Okay, so mainly drawing the structure and their properties and their way of understanding is only the difficult. Okay, so let us start with the first example, XeF2. Okay, what is the first example? XeF2. So I will be little bit faster. Okay, so you should be able to cope up with that. So here what is the electronic configuration of the xenon? It is the 5s2 5p6. What is the electronic configuration of xenon? It is first I will write the Xe. It is 5s2 5p6. Okay, now 5s2 5p6, 5s2 5p6. So we got 5d also. What we got? We got 5d also. But we have lot of facility to accommodate the electron, but we will not accommodate as per the availability. We will accommodate as per the requirement. Like here 2 electrons are required, so this electron will go from here to here. Okay, so then it will be 5s2 5p6 will become as what? 5p5, and 5d will remain as 1. Okay, so 5s2 will remain as it is, 5p5 will remain like this, and 5d1 will be like this. Okay, so this is the electronic configuration, and why it is only, is it understood? 2 unpaired are required, only this is sent as a excited state. Okay, now this is the hybridization. See, 1 s orbital, 3 p orbital, 1 d orbital. Okay, sp3d. What is the hybridization? sp3d and 1 2 3. So 3 are already lone pair, and 1 2. So those two, what they will make? They will make the bond pair. Okay, so sp3d with 3 lone pair and 2 bond pair. So as per the sp3d, what should be the structure is, it should be trigonal bipyramidal. Okay, this is the xenon. What it is? It is a xenon, and it is being formed as a triangular bipyramidal. Okay, so I am drawing with the blue color so that it should look beautiful and attractive. Okay, so I have to keep 3 lone pair at one place, 2 bond pair at one place. Which are the best position to keep the lone pair and bond pair? The best position to keep the lone pair is at the vertices of a regular triangle. Okay, why? Because lone pair got the more repulsion. They are to be kept at the largest bond angle. This is the largest bond angle possible, and one fluorine will be here, another fluorine will be here, like this XeF2. Okay, so what is the shape? It is linear shape. Is it understood? Any doubt about this? So this is how you will draw the structure. I explained with the reason what as per this should be there, and because of the lone pair like that. Okay, now we are going to continue with the same. What is the next one? XeF4. For that, is it sufficient? If you wanted to take a notes, you can pause it over here and take a notes. Okay, now XeF4 we have done. Sorry, XeF2 we have completed. We are going to for the XeF4. Is this sufficient? No, we require how many electron unpaired? We require 4 unpaired electron. For that, I need to excite this electron also. I need to excite this electron also. Now see, I can accommodate 4 unpaired. So what will be the hybridization? One more d orbital increased. So sp3 d2. but lone pair decreased. What is the lone pair now? 2 lone pair. But bond pair increased. What is the bond pair now? 4 bond pair. Now once hybridization changes, there will be change in the structure also. Okay. According to sp3d2, what should be the structure? Okay. So in the center, who will be accommodated? In the center, it will be accommodated by the xenon, and it is square and it is bipyramidal. Okay. So square bipyramidal. What is the structure? Square bipyramidal. And in the square bipyramidal, we can keep the lone pair. How many lone pair? 2 lone pair. And how many bond pair? 4 bond pair. 2 lone pair and 4 bond pair. So what we will do, there is no chance of the less and more bond angle. Here also 90 and here also above below also 90. So we can keep it anywhere. But better to keep lone pair top and bottom of a square. And on the square, all should be given with equal importance or not. So for that, what I will do, all fluorine together on the vertices of a square. On the vertices of what? Square. Okay. And xenon is above and below. Xenon is where? Above and below. Is it understood? So this is what it is called as square. Actually it is used to be bipyramidal. But one pyramid lone pair and another pyramid also lone pair. So left over with the square planar. XeF4. What is the structure? Square planar. Okay. Structure of XeF4 is what? Square planar. Now we are left with what? XeF6. Okay. So XeF6 will be pentagonal bipyramidal. How I will explain it? Similar way as I explained here. XeF4 will become as XeF6. Then this will not be sufficient. This also will go this side. So this will become this side. Oh, previously I could not change this one. Now 5D3 and this will be 5P3. Okay, in the previous example I should reduce this also, but I did not reduce. Okay, so for this up to here it is the 5s2 5p3 5d3. Now hybridization will be sp3d3, and what will be the one lone pair, and what will be the answer here? 6 bond pairs. Okay, so 5 sp3d3. What should be the shape? Pentagonal bipyramidal. Okay, what should be the shape? Pentagonal bipyramidal. XeF6. This is the pentagon, this is a bipyramid. Okay, now here only one lone pair is there. Where I should accommodate? Here again bond angles are different. Here bond angle is 72 degree, here bond angle is 90 degree. Okay, so better to keep the lone pair over the top, because maximum bond angle is there. Okay, so fluorine, 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 fluorine. All the vertices of a regular pentagon is occupied by fluorine, and one bottom also. Okay, one bottom also it is fluorine. So what it is called as? Pentagonal pyramidal. What it is called as? Pentagonal pyramidal. Is it understood, all of you? Any doubt about this? So this is very easy because only sigma bonds are there. Okay, but when you come to the oxides, it is little bit difficult. Not much difficult. If you are perfect in fluoride, then it will be easy for you to understand oxides also. Okay, in oxides examples are also less or not. How many examples I told you? 2 examples, XeO3 and XeO4. Okay, let us start with the, now there will be lot of changes, so better I will erase everything. Okay, first let us start with what? Xe, where first example if you listen carefully, then other will be easier one. Okay, XeO3. All of you are aware that every oxygen can form how many bonds? 2 bonds. Likewise 3 oxygen, 6 bonds. So I should provide how many? 6 unpaired. So what I will do? 1, 2 and 3. Okay. Now the electronic configuration will become 5s2, 5p6 will become what? 5p3, and 5d will also be 3. Okay. but one change is that pi bond electron should not be hybridized. Which should not be hybridized? Pi bond electron should not be hybridized. Okay, so this is the case. Okay, now in this condition, pi bond, 3 pi bonds are there. This is also, this is also, this is also. Because simple rough diagram, if I write xenon, double bond and double bond. Simple also, if I change 3 sigma bond and 3 pi bond. So 3 pi bond should not be included in the hybridization. So what will be the structure here? sp3. But in sp3, one lone pair, and how many bond pair are there? 3 bond pair. As per the sp3, what should be the structure? Okay, structure must be xenon and double bond oxygen, double bond oxygen, double bond oxygen. But here what you will find? You will find a lone pair. What you will find? Lone pair. So this is the structure of a xenon trioxide. What it is called as? Pyramidal. What it is called as? Pyramidal. Okay. So first oxide structure, I think it is understood now. Any doubt about this? Okay. So if you don't have doubt, then we will not have any doubt about XeO4 also. Okay. So XeO4, what will be the shape? One more oxygen will come here, one more sigma bond, one more pi bond. For that, one more electron will go here. So 5s2 will become as 5s1 and 5d3 will become as 5d4. So 4 pi bonds. Now hybridization will be as it is. But number of bond pair increased to how many? 4 bond pairs. How many bond pairs? 4 bond pairs. So there is no chance of the lone pair here. What I will do directly, I will make it as directly like this. So now it will be complete tetrahedron. There is no chance of the shape change. There is no chance of what? Shape change. Okay, this is the pyramidal shape. I think all of you understood or not? So this is about the oxides. Now we are left with what? Oxy Flourides. There are lot of Oxy Flourides, but what I will do, I will explain 1 or 2 so that you should understand easily and you should be able to solve other one. Okay. First I am taking XeOF2. Okay. What I am taking? XeOF2. Some things you need to practice or not? XeOF2. So first we should assess that what is our requirement. See, Xe, oxygen will be double bond, fluorine will be single bond. Okay. Now if there is only one bond, it will be obviously sigma bond, pi bond, sigma bond. Okay. So xenon is forming how many bonds total? 4 bonds, out of which 3 are sigma bond, 1 is pi bond. 3 are sigma bond and 1 is pi bond. Okay. So XeOF2, in this I should provide how many unpaired electron? I should provide total 4 unpaired, but how many of them should be hybridized, how many of them should not be hybridized is a good question, is a difficult question, is an important question. Okay. So first I should provide how many unpaired? 4 unpaired. Number of bonds it is forming should be equal to number of unpaired electron. Okay. So if I make like this, 2 unpaired will be there. If I make like this, 2 more unpaired electron, that means 4 unpaired electron. That's sufficient to me. Okay. Now there is no change in the 5s. This will be 5s2. And there is change in the 5p6. 2 electron gone. So it will be 5p4. And 2 electron added, 5d2. Okay. So 5s2, 5p4. Now question arises, how many of them should be hybridized? All should not be hybridized. See, 1 pi bond. Pi bond you mark it like this. Okay. Then up to here you will start hybridizing. Okay. So what will be the hybridization? sp3 dehybridization with how many bond pair? With bond pair of 2 lone pair. Okay. And 3 bond pair. 1, 2, 3. 3 bond pair. So according to sp3d, what must be the shape? Okay, good. It should be the triangular bipyramidal. So what I will write? Xenon, xenon, okay, triangle and bipyramid. Now I have to keep lone pair. Where it is better to keep the lone pair? Wherever bond angle is maximum, where it is in the triangle. So I will accommodate one lone pair here, one lone pair here. Now one oxygen and two fluorine. For beautification, what I will do, I will make this as a double bond and arrange oxygen here, fluorine here, fluorine here. Okay. So without this, it appears like this or not? Oh shit. Xe, F, F, and is it inspires you about some alphabet? Okay, that alphabet is none other than T. That's why this is called as a T shape. What it is called as? T shape. Difference in oxides, fluorides and oxy fluorides. Now I think you understood or not. I will take one more example. Then you will be easy to understand the remaining part. Then I will be taking what? XeOF4. XeOF4. So because of this, two more fluorines are coming out. So now bonds become how many? 6 bonds. So out of 6 bonds, 5 will be sigma bond, 1 will be pi bond. So total 6 unpaired electron I should provide. So I will make this also go that side. This 5p4 will become as 5p3 and 5d2 will become as 5d3. Okay. So I will be explaining some important concepts also. So better to stay with me. Okay. So 5d3. Now unpaired, these are the, okay, this is the 5p3, 5d3. Is it correct now? Okay. Now this will be the pi bond and up to here hybridization. sp3d2, 1 lone pair, 1, 2, 3, 4, 5 bond pair. Okay. So what is the answer here? sp3d2. What should be the shape? Square bipyramidal. What should be the shape? It should be square bipyramidal. Okay. So for square bipyramidal, what I will do? What I will do, tell me. I will do it as a square at the center. Okay. And pyramid. But main problem is that one lone pair is also there. So what I will do, tell me. I will accommodate the lone pair at the top. Okay. And what I will do, tell me. I will accommodate the oxygen at the bottom with double bond. See how beautiful it looks. Okay. Fluorine, 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 fluorine. Okay. Now it looks as if it is a square pyramid, not bipyramid. It is only, this is not considered as a pyramid. Only bottom side it is pyramid. So what is the structure? Square pyramid. Is it understood? Any doubt about this? Okay. Should I take one more example? Okay. Then I will take one thing. XeO2 F2 I will take. Okay. Now problem is that two oxygens, this electronic configuration matches it. 2 oxygens 4 bonds and 2 fluorine 2 bonds. 4 plus 2 6 bonds. So 6 unpaired electrons are there. But number of pi bonds are different. What are different? Number of pi bonds are different. So I should make accordingly or not? See, Xe double bond F F. Okay. So how many sigma bonds? 4 sigma bonds. How many pi bonds? 2 pi bonds. So 6 unpaired, 2 pi bond, 1 and 1. So from here to here, it will be the hybridization. So what will be the hybridization? sp3d. But 1 lone pair and 4 bond pair. How many lone pair? 1 lone pair and 4 bond pairs. Okay. So out of this 1 lone pair, 4 bond pair, what I will do according to the sp3d, what should be the shape? Triangular bipyramidal. Okay. Xe double bond, 1, 2, 3 triangular bipyramid. Okay, in the triangular bipyramid, one lone pair also there, where it is to keep, better to keep here or not. Why? Bond angle is more. Okay, whenever there is a lone pair, you should feel that it should be kept as possible as away. So where away? Where bond angle is maximum. So left over with 2 oxygen and 2 fluorine. Now better I will feel that this should be double bond, this should be double bond. 1 oxygen here, 1 oxygen here. Okay, and 1 fluorine here, 1 fluorine here. Okay, so see how it appears. Xenon, fluorine, fluorine, and oxygen, oxygen. Okay, this is a lone pair. This is called as a seesaw. Which saw? Seesaw shape. Okay, so this is all about the type of compounds of xenon. Xenon forms how many compounds? 3 type of compounds. Number of compounds are more. Okay, what are those number of compounds? Oxides. Type of compounds are oxides, fluorides, and oxy flourides. So I have covered to the maximum extent. Today's main topic we have covered is clatherate, what prompted Bratlett, and what are the compounds of xenon. I think you liked it, and leftover examples which I told you to do it your hybridization and structure on your own. So try to do it immediately. The best time to do work, chemistry work, is now. Okay, if you cannot do it now, then you may not be doing any time. Okay, so I think all of you will write a good notes and useful for your bright career. Okay, see you, bye bye.